So I came across this paper recently from Anthropic. The paper is Privacy Preserving Insights into Real World AI Use. CLIO means Claude Insights and Observations. This is a very innovative approach in finding out how the humans and AIs are interacting with each other. Are there any harmful interactions, right? How can I cluster those interactions into uh, similar conversations? I group them to see if somebody is trying to mess with my agents, if somebody is trying to um, jailbreak the agents. And overall, how can I ensure that the interaction is happening in a safe and secure way? But while clustering that interaction information, the approach ensures that any private information is discarded from the from the analysis, right? Uh, so this picture here um, explains this approach at a very high level, where you have multiple conversations, your conversation or your interaction corpus. You um group them into hierarchical clusters, right? When you group them into hierarchical cluster, you ensure that any private information is not included in the clusters, right? And then after you create those clusters, right, you can use it for broader usage insights, like find out what are the common topics that are being discussed. You can cluster by language to see if demographically are there any unique patterns by demography. What are the noteworthy clusters and all, right? So I went through this entire paper and summarized it here in my blog. And I named the blog as "Are You Messing with My Agents?" Right? Later, I'll show you how I have also implemented this algorithm into a Python code, right? But before that, let me touch upon some important parts of this paper. Uh, so the key principles of CLIO is privacy preserving analysis. What that means is that no human reviewers can access the raw conversations. Only aggregated insights are analyzed, right? And this is actually a technique that we have used in traditional machine learning model also, to ensure that there is no way to bias by uh, individual individual attributes, right? For example, um, in a locality, instead of doing an analysis a by a particular person's race, religion, creed, right? We can actually aggregate at a higher level. So we do aggregated analysis so that it doesn't allow us to identify a certain person, so that we can stop this AI or this machine learning algorithms to bias against a single person, right? So privacy preserving analysis, a similar technique where the aggregated insights are analyzed instead of the insights at a individual level, right? Semantic clustering, where AI-based categorization groups similar instructions so that we can cluster them into meaningful cluster that can be analyzed. Hierarchical organization, insights are then structured for better navigation and comprehension. And here the approach talks about agglomerative clustering, where you can come from a uh, coarse-grained hierarchy to a more fine-grained hierarchy. Exploratory search, after you create the clusters, right? You can further do multi-turn um, conversation with LLM to identify more new patterns from the analysis, right? The approach that it takes is, the first approach is to collect the interaction, the corpus, right? So gather a large corpus of AI assistant interaction. Then you remove the identifiable user data to comply with privacy standards, right? And then you tokenize and embed the conversation. Next, you identify the key facets, such as what type of language it is. Is it a Hindi language or English language, Chinese language? What is the topic classification? What is a conversational lang? What is the complexity of the conversation, right? You try to extract those. Then you do the semantic clustering to convert the text into embeddings, and then do k-means clustering to group similar conversations together, right? Then you create a summarization of the cluster and filter out clusters that can contain potentially private information, right? And then organize the clusters into a structured tree view. And as I was telling, like use agglomerative clustering to create multi-level groupings or multi-level hierarchies, right? The way the approach enforces privacy is in 4 stages. First stage is where summarizing the conversation, you omit individual user identifiers. Next, when you are creating the clusters, right, you enforce a minimum cluster size, right? So that a cluster that is formed of a small number of accounts are discarded, right? Because if you create a cluster with just one account, you can identify whose account that is, right? So if the cluster is formed of minimum number of accounts, you discard it, right? So that you cannot identify it to a particular person. While creating the cluster summaries, the model is instructed again to remove the private information. And the model is again used, a language model is again used to audit the summaries and discard any clusters that may have any private information. Now this, as I said, use cases of this are many. One of them is the model usage analytics, understanding how users are interacting. Are the users messing with my agents? The AI safety monitoring, market and business insights, and any governance and ethical compliance, right? Now let's actually show an example where I have tried to implement this algorithm that is mentioned in this paper, right? So let's say these are my conversations, right? I created a synthetic set of conversations where, if you see, there are PII data and all, right? And then I created a function with remove PII, extract facet, then I compute embeddings, clustering the text using k-means clustering, summarizing text using GPT-4o, generating a topic name with GPT-4o, then visualizing the clusters, right? Then in the main program, I load the conversations, create the facets, create the embeddings, then I do the clustering, right? Number of clusters, I bind it to 3. And then for each cluster, again, like create a cluster map, and then create the topic names for the cluster, summarize the texts for the particular cluster, right? And finally, I visualize the clusters by passing the embeddings, the labels, and the cluster topics, right? So if I run this, you'll see how it is actually clustering the this set of conversations, right? So here I wanted to cluster them by user preference, right? So related user preferences will be clustered together, but it will redact the PII data if there are any in the conversation. So there are multiple here, right? So you have phone number, we have email, right? So those will be removed from the thing. So it started creating the cluster. This is my, I said 3 clusters, right? The cluster 0 is like the user preference is passions, like culinary fitness and minimalistic design. So this set of conversations fall into this cluster. Okay, so this is the uh, the cluster, the visualization of the clusters, right? So we have 3 clusters, right? So 1, 2, 3, 4. 4 conversations. This is the topic that I have created, fall into one cluster. Then I have this 2 cluster, 2 conversations fall into this cluster, and 3 conversations fall into this cluster. So passions, culinary fitness, and minimalistic. Let's actually look at it here again. So passions, culinary fitness, and minimalistic design. These are the 3 conversations that fall under this cluster. this is a summary of the cluster, right? So I enjoy cooking and experimenting. I want to start a fitness routine. I prefer minimalistic interior design, right? Second cluster is leisure activities. My phone number, see, it is redacted, right? So these are the four conversations that fall under this cluster. Then cluster two is eclectic taste in genre fiction and film. I love sci-fi films. I'm looking for recommendation fantasy films with rich world building. I'm a fan for horror movies, but I also like psychological thrillers, right? So this is a attempt by me to implement uh, this particular algorithm that is mentioned in the um, paper, right? I The hierarchical part I still have not implemented here. I have directly used k-means clustering, but I think there is a way we can do agglomerative clustering also to create a coarse-grained hierarchy and then go to a fine-grained hierarchy, right? But that's what I wanted to talk about, and this is definitely a paper that is very innovative, and I see that there are a lot of use cases where we can use this approach. That's all. Thank you.